When installing 30 amp hand dryers, it's crucial to understand the neutral conductor requirements, especially when running multiple circuits in a single conduit. The National Electrical Code, or NEC, dictates that each circuit must have its own dedicated neutral conductor. You cannot share a single number 10 white wire as the neutral for two 30 amp circuits within the same conduit. The reason for this requirement lies in how current flows in alternating current or AC circuits and the potential for overloading the neutral conductor as well as unwanted harmonic current. In a standard single-phase circuit, the neutral conductor carries the imbalance of current between the hot or energized conductors. However, when you combine multiple circuits, each with its own load, the neutral can become a path for additive currents. To illustrate this, consider two separate 30 amp circuits powering the hand dryers. Each circuit has a hot conductor and a neutral conductor. If both circuits are fully loaded, each hot conductor will carry 30 amps, and each neutral conductor will also ideally carry 30 amps. Now, if we were to consolidate both neutrals into a single number 10 wire, that wire would then be subjected to potentially 60 amps, and possibly more due to harmonics. This would exceed the ampacity of a number 10 wire, which is typically rated for 30 amps, depending on the insulation type and installation conditions, violating NEC section 310.15. There are exceptions when a single neutral conductor can serve multiple circuits, such as multi-wire branch circuits. These exceptions, however, do not apply to the scenario with individual 30 amp hand dryer circuits. A multi-wire branch circuit shares a single neutral conductor between two or more ungrounded conductors that derive their power from a single-phase 3-wire system or from 3 phases of a 3-phase system. The voltage between the ungrounded conductors is higher than the voltage between any ungrounded conductor and the neutral conductor. For instance, in a typical 120/240 volt single-phase system, the voltage between the two hot legs is 240 volts, while the voltage from each hot leg to neutral is 120 volts. In a 208Y/120 volt 3-phase system, the voltage between any two hot legs is 208 volts, while the voltage from each hot leg to neutral is 120 volts. The key characteristic of a multi-wire branch circuit is that the neutral conductor only carries the imbalance of the currents between the ungrounded conductors. If the loads are balanced, the neutral current is minimal. This configuration is typically used for general-purpose receptacles and lighting, but is not suitable for dedicated high-amperage loads like 30 amp hand dryers. The NEC provides clear guidelines on conductor sizing and ampacity. For a 30 amp circuit, the minimum conductor size is typically number 10 AWG copper wire, assuming the use of the common type THHN, THWN, or similar insulation rated for 75 degrees Celsius. The ampacity of a conductor is determined by several factors, including its material, insulation type, size, and installation environment. NEC Table 310.16 provides ampacity ratings for conductors based on these factors. It is essential to consult this table to ensure that the selected conductor has sufficient ampacity for the intended application. Furthermore, the NEC addresses the installation of conductors in raceways such as conduits. When multiple current-carrying conductors are installed in the same raceway, a directing factor may need to be applied to the conductor ampacity. This is because the heat generated by the conductors can accumulate within the raceway, potentially exceeding the conductor's temperature rating. NEC section 310.15 cone outlines the adjustment factors for conductors in raceways. If the number of current-carrying conductors exceeds 3, adjustment factors ranging from 80% to 45% may be required. This derating is in addition to any other derating factors that may apply. For instance, if you have 4 to 6 current-carrying conductors in a conduit, you must apply a derating factor of 80% to the conductor's ampacity. This means that a number 10 AWG conductor with an initial ampacity of 30 amps would be derated to 24 amps. In the case of the 30 amp hand dryer circuits, each hot conductor and the neutral conductor are considered current-carrying conductors. Therefore, if you were to run two 30 amp circuits in the same conduit, you would have 4 current-carrying conductors, requiring a derating factor of 80%. The NEC also specifies requirements for conductor identification. The neutral conductor must be identified by a continuous white or grey covering. This helps to distinguish the neutral conductor from the hot conductors, which are typically black or red. The grounding conductor, which provides a path for fault current, must be identified by a continuous green covering, or green with one or more yellow stripes. Proper conductor identification is crucial for electrical safety and troubleshooting. In addition to conductor sizing and identification, the NEC also addresses the requirements for overcurrent protection. Each circuit must be protected by a circuit breaker or fuse that is rated to protect the conductors from overloads and short circuits. The overcurrent protection device should be sized to match the ampacity of the conductor it is protecting. For a 30 amp circuit using number 10 AWG conductors, a 30 amp circuit breaker or fuse is typically required. It is important to select overcurrent protection devices that are listed and labeled for the intended application. The NEC also provides guidelines on the installation of electrical equipment. Electrical equipment must be installed in a neat and workmanlike manner. Conductors must be properly supported and secured. Connections must be made using approved methods. The equipment must be readily accessible for inspection and maintenance. Proper installation practices are essential for electrical safety and reliability. To summarize, when installing 30 amp hand dryers, remember that each circuit must have its own dedicated number 10 AWG neutral conductor. You cannot share a single neutral conductor between multiple circuits. The NEC mandates this to prevent overloading the neutral conductor and ensure electrical safety. Consult the NEC and local electrical codes for specific requirements and guidance on conductor sizing, ampacity, rating, identification, and overcurrent protection. Always follow safe electrical practices and consult with a qualified electrician if you have any questions or concerns. Furthermore, consider the impact of voltage drop on the performance of the hand dryers. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to operate inefficiently or even fail. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, select conductors with sufficient size and minimize the length of the circuit. Calculate the expected voltage drop based on the conductor's resistance, the circuit's current, and the circuit's length. If the voltage drop exceeds the recommended limits, increase the conductor size or reduce the circuit length. Also, consider the grounding requirements for the hand dryers. The NEC requires that all metal enclosures of electrical equipment be grounded. Grounding provides a low impedance path for fault current, helping to protect people from electric shock and equipment from damage. The grounding conductor should be sized according to NEC Table 250.122, based on the rating of the overcurrent protection device. The grounding conductor should be connected to the equipment grounding bus in the electrical panel. Ensure that all grounding connections are tight and secure. When selecting hand dryers, consider their energy efficiency. Energy-efficient hand dryers can save energy and reduce operating costs. Look for hand dryers that are ENERGY STAR certified. These hand dryers meet specific energy efficiency requirements. Also, consider the noise level of the hand dryers. Some hand dryers can be quite noisy, which can be disruptive in an office environment. Look for hand dryers that have a low noise rating. Consider the drying time of the hand dryers. Faster drying times can improve user satisfaction. Look for hand dryers that have a high air velocity and a focused airstream. Also, consider the maintenance requirements of the hand dryers. Some hand dryers require more maintenance than others. Look for hand dryers that are easy to clean and maintain. Choose hand dryers that are durable and reliable. Select hand dryers from reputable manufacturers with a proven track record. Read customer reviews and ratings to get an idea of the hand dryer's performance and reliability. Before installing the hand dryers, obtain the necessary permits from the local authorities. Electrical work typically requires a permit to ensure that it complies with the applicable codes and regulations. The permit process may involve submitting drawings and specifications and undergoing inspections. Schedule the electrical work to minimize disruption to the office environment. Coordinate with other trades, such as plumbers and carpenters, to ensure that the installation is properly coordinated. Provide adequate lighting and ventilation for the electrical work area. Use appropriate personal protective equipment, such as safety glasses and gloves. To energize the circuits before starting any electrical work. Verify that the circuits are de-energized using a voltage tester. Lock out and take out the circuit breakers to prevent accidental energization. Follow all applicable safety procedures and regulations. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical work can be dangerous, and it is important to have it done by someone who is trained and experienced. A qualified electrician can ensure that the electrical work is done safely and correctly, and that it complies with all applicable codes and regulations. After the hand dryers are installed, inspect the installation to ensure that it is done correctly. Verify that all connections are tight and secure. Check the voltage and current to ensure that the hand dryers are operating properly. Test the grounding system to ensure that it is functioning correctly. Provide training to the office staff on how to use the hand dryers safely and efficiently. Explain the importance of not overloading the circuits and of reporting any problems with the hand dryers to the facilities manager. Establish a maintenance schedule for the hand dryers. Regularly clean the hand dryers and check for any signs of damage or wear. Replace any worn or damaged parts promptly. Keep a record of all maintenance activities. By following these guidelines, you can ensure that the 30-amp hand dryers are installed safely and correctly, and that they provide reliable and efficient service for many years to come. Always remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. If you are unsure about any aspect of the installation, consult with a qualified electrician.